Hey everyone, so I'm going to be going over just number 4 and number 5 on your review for the test. In my last video, I went over how to do graphing and properties and how to write an equation from a graph, which covers the first 3 questions on your review. So if you're having a hard time with those, you can look back at that video for help, even though it's different problems. But I will do number 4 and number 5. Since those are the new topics we've learned since the last quiz. So for number 4, we're converting either from standard to asymptote form or from asymptote form to standard form. So the first one gives us something in standard form, so that means we need to find the asymptote form. So to do that, we have to use polynomial long division. So we start by putting the numerator, which is 3x plus 15, underneath the division sign. And then x plus 2 goes on the outside because that's what we're dividing by. And the first thing we do in polynomial long division is look at the first term on the outside and the first term on the inside. And we have to think x times what will give us 3x. And of course, that would have to be 3. So that means 3 is the number that goes on top. The second step with long division is to multiply both terms on the outside by that number on top. So x times 3 gives me 3x. 2 times 3 gives me positive 6. So my next step is to subtract. I have to subtract both of the terms I just wrote down. So I have to subtract 3x and subtract 6. So 3x minus 3x cancels, and 15 minus 6 becomes 9. Okay, so normally I would go on and try to figure out x times what gives me 9, but there isn't anything I can multiply x by to get a constant like 9. So that means that I'm done, and I just have a remainder of 9. So I'm now able to write my asymptote form. So of course, don't forget to use your function notation. So f of x equals, and then the whole number is going to be the number I got on top. So that means when I took 3x plus 15 and divided it by x plus 2, I got 3 wholes, plus I got a remainder of 9, which is still being divided by x plus 2. So again, the number on top is the whole we get out of dividing, and then 9 is the remainder. So the remainder is still, it never got to be divided by x plus 2 because x plus 2 doesn't go into 9. So that's kind of what's left over on top of the denominator that we already had. So 3 plus 9 over x plus 2 is our asymptote form. Remember, the whole point of converting from standard to asymptote form is that it's easier for us to graph this function because we know what the asymptotes are. All right, so next one, we're given the asymptote form and we need to do the standard form. So I'm given 1 plus 5 over 3x plus 2. So the way we do this is we take the whole number, multiply it by the denominator, and then add the numerator. So I'm going to do the whole number, which is 1, times the denominator, which is 3x plus 2, plus the numerator, which is 5. And then I keep the denominator 3x plus 2 on the bottom. So don't forget to keep that denominator. Now with this, I just have to simplify. So the 1, if I distribute the 1, I'm just going to end up getting 3x plus 2. Okay, let me write this a little lower because I get 3x plus 2 and then plus 5 divided by 3x plus 2. Okay, and then now I just have to simplify a little bit. 2 plus 5 gives me 7, so I get 3x plus 7 over, sorry, that does not look like an x. 3x plus 7 over 3x plus 2. So that's all you have to do, is you do whole number times the denominator plus the numerator. Just simplify on top, and it's all divided by the denominator we had before. So I can write that over here as f of x equals 3x plus 7 divided by 3x plus 2. All right. Last one. Again, we're given something in asymptote form. So I take the whole number, which is 3, multiply it by the denominator, which is x minus 5, and then plus the numerator. But in this case, there's a minus sign here. So instead of doing plus the numerator, we can think of it as plus negative 3. We'll just keep the negative with the 3, or we can just write minus 3. We don't need to write plus a negative. It's the same as subtraction. And then we keep x minus 5 in the denominator. Okay, now I just need to simplify, so I can distribute 3 to my x and my negative 5. 3 times x gives me 3x. 3 times negative 5 gives me negative 15. And then minus 3 divided by x minus 5. Okay, so 3x minus 15 minus 3 gives me minus 18. And then divided by x minus 5. So that's my function. So f of x equals 3x minus 18 divided by x minus 5. All right. So remember, use long division to go from standard form to asymptote form, and then you add rational expressions to do asymptote form to standard form. All right, now I'm going to do all these solving problems. So the first one, 4 over x plus 3 plus 2/3 equals 4 over x plus 3. So here I see two different denominators. I see x plus 3 as one denominator, and then I see 3 as another denominator. And I know that to solve this, I want to get rid of my denominators. The way I'm going to get rid of a denominator is by multiplying by that denominator. So if I start with 3, if I want to get rid of 3, I know I want to multiply everything by 3, because I can't just, I know I want to multiply this one by 3, but I can't just multiply that by 3. I have to multiply everything by 3. But that's not going to get rid of x plus 3. So I also have to multiply everything by x plus 3. X plus 3. Okay, so I'm multiplying every single term by 3 and x plus 3, because those are the two denominators I have. So now I have to cancel those out, or cancel out what I see. So in the first one, I know that the x plus 3 is going to cancel out on the top and the bottom. And the second one, the 3 is going to cancel out on the top and the bottom. And then the last one, the x plus 3 is going to cancel out on the top and the bottom. If your denominators don't all cancel out, then you made a mistake. The whole point of multiplying in the first step is to get rid of those denominators. So for the first term, we're left with 4 and times 3. Don't forget about the times 3. Plus, in the second term, we're left with 2 and x plus 3. And then on the right side, we're just left with 4 times 3. Okay. So that gives us 12 plus, we distribute here, so we get 2x plus 6 equals 12. Now I can just combine some like terms. So 12 plus 6 gives me 18. So I have 2x. I have 2x plus 18 equals 12. Subtract 18 on both sides. 2x equals negative 6. Divide both sides by 2, and I get x equals negative 3. There's one more thing you have to do. You have to check and see if your solution is extraneous. So you don't necessarily have to go back and do all the work of plugging it in. But what I do see is that in my original equation, I had x plus 3 in the denominator. So if I, for example, I could just look at the 4 over x plus 3. And I know that if I were to plug in negative 3 here, I would get 4 over negative 3 plus 3, which gives me 4 over 0, which is bad, right? I can't divide by 0. That's not allowed. So that means that this solution is extraneous. So you can just write EXT for extraneous. So you really do have to check your solutions to see if you get something extraneous. Again, the way you can go back and make sure your solution works, but if you're just checking to see if it's extraneous, you really just need to look at all the denominators in the original equation and see if you could get 0 when you plug in your solution. All right, let's do another one. So thinking still about the extraneous thing, I can also look at this equation, 4 over x minus 3 equals 2 over x plus 2. I can just look at this and figure out pretty quickly what x values cannot be the answer. So I know that x cannot be 3, because if I plug that in to the left side of the equation, I would get 0 in the denominator. And then on the right side, x can't be negative 2, because if I plug that in, I would get a 0 in the denominator. So I can also just look at the beginning, know that x can't be 3 or negative 2, do my solving, and then at the end, make sure I didn't get 3 or negative 2. And if I did, then I just have to say it's extraneous. Okay. So again, here I see I have two denominators. I've got x minus 3, and I've got x plus 2. So that means if I want to get rid of those denominators, I need to multiply by both of them, everything by both of them. So I'll start by multiplying by x minus 3. This is going to be messy, I apologize. And then I also need to multiply by x plus 2. Now I need to go in and see what cancels. In the first one, the x minus 3 cancels, as it should. And in the second one, the x plus 2 cancels. So that means on the left side, I'm left with 4 and x plus 2. And on the right side, I'm left with 2 and x minus 3. Now I just need to distribute. So 4 times x gives me 4x, plus 4 times 2 gives me 8. 2 times x gives me 2x, minus 2 times 3 gives me 6. I don't see any like terms on each side, but I can move my terms around so that I can combine them. So I could start by subtracting 2x on both sides. So that gives me 4x minus 2x is 2x, plus 8 equals negative 6. And then I can subtract 8 on both sides. Remember, I'm solving for x here, so my goal is kind of to get x by itself. So if I see the x terms on each side, I need to move them together. Now here I get 2x equals negative 14. And then if I divide both sides by 2, I get x equals negative 7. So I can just look real quick, and I already wrote up at the top that I know x can't be 3 and x can't be negative 2. And so that means negative 7 is not an extraneous solution, because if I were to plug it in, I wouldn't get a 0 in the denominator. All right, the last two have some factoring, no worries. So for the one on the left, I'll start by trying to factor this denominator x squared plus 4x plus 3. So I would need to think what multiplies to 3 and adds to 4. So that would be 3 and 1. So that means this factors to be x plus 3 times x plus 1. And that is not a surprise, because that is the two denominators I have on the left side. I would always just check that, if you don't want to think about factoring, at least check in your head that, 1 and 3 multiply to 3 and add to 4. But yeah, that's how it's supposed to work. So since I have the only factors I have in all my denominators are x plus 1 and x plus 3, I can go ahead and multiply everything by x plus 1 and everything by x plus 3. So I'll multiply my first one by x plus 1 times x plus 3. This is going to be really messy, and give myself a little more room. Okay, I'm going to multiply this one by x plus 1. Oops. X plus 1 and x plus 3. this one by x plus 1 and x plus 3. And this one by x plus 1 and x plus 3. So remember, the goal here is for everything to cancel. So I see here the x plus 1's cancel. Not everything cancels, I should say. The denominator should all cancel. Here the x plus 3 cancels, and here both of them cancel. So that leaves me with x and x plus 3 in the first term, plus 4 and x plus 1 in the second term, equals 22. Let's scroll down a little more now. Okay, so now I need to distribute. So x times x gives me x squared. X times 3 gives me 3x. 4 times x gives me 4x. 4 times 1 gives me 4. So now I can combine like terms, 3x and 4x. So I get x squared plus 7x plus 4 equals 22. So since I have an x squared, that means this is going to be a quadratic equation, which means I'm going to have to factor. So if I want to factor, I need my equation to be set equal to 0. So that's why I'm going to subtract 22 on both sides. So I know you're wondering, like, why didn't we have to do that in the last two problems? That's because we didn't have any x squareds. We just had x's. We were able to combine them and solve since it's a linear equation. But this is quadratic because we have an x squared. So we want it to be set equal to 0. So I have x squared plus 7x minus 18 equals 0. So then I have to think what multiplies to negative 18 and adds to 7. If you're having a hard time, you can make some factors of 18, 1 and 18, 2 and 9, 3 and 6. And if they need to multiply to a negative and add to a positive, that means 1 should be negative. So it will have to be 9 and negative 2, because 9 minus 2 gives me 7. So that means I have x plus 9 times x minus 2 equals 0. And that gives me two solutions. X equals negative 9, because if I plug that in, I would get 0. And x equals 2, because 2 minus 2 would give me 0. Now, don't forget, we got to check for extraneous solutions. So I need to look and see if I were to plug in negative 9 or 2 in my original equation, would I get 0 in any of the denominators? And since I had x plus 1 and x plus 3 in the denominators, negative 2 and 9, or 2 and negative 9 would not give me a 0 in any of the denominators. The numbers that would give me 0 would be negative 1 and negative 3. So I'm good. Neither of these are extraneous. All right, last one. So again, as you can probably guess, since we have to factor, you can kind of assume, but check that x minus 1 and x minus 3 are our factors. So I need to think, do negative 1 and negative 3 multiply to positive 3 and add to negative 4? And they do. So that means this can be rewritten as x minus 1 times x minus 3. So that means to get rid of the denominators, I just need to multiply everything by x minus 1 and by x minus 3. All right. So now I have to cancel out my denominators. So here the x minus 1's go away, here the x minus 3's go away, and here everything goes away. So now I'm left with 2x times x minus 3 plus 1 times x minus 1 equals 2. So if I distribute, I get 2x squared minus 6x plus 1 times x minus 1 just leaves me with x minus 1 equals 2. I can combine my like terms. Negative 6x plus x gives me minus 5x minus 1 equals 2. Again, this is quadratic, so I need to get everything on one side. So it's set equal to 0. So I get 2x squared minus 5x minus 3 equals 0. So you're probably like upset because there's a a 2 in the front, but I'll actually you can use box method, but you can also kind of just guess and check. So I know that I need to always multiply my first number with my last number to think about factoring this. So 2 times -3 gives me -6. So I need to think what multiplies to -6 and would add to -5. So I've got 1 and 6 and 2 and 3. If it needs to multiply to a negative and add to a negative, one of them has to be negative. So the two numbers that multiply to -6 and then add to my -5 are going to be 1 and -6. So that just means that, well, this helps me because I know that when I FOIL this out, I have to get 2x squared minus 5x minus 3. The first thing I usually think about if I'm trying to guess and check is that I have to have an x in both. I know that. And the only way to get 2x squared is to have a 2 in front of one of these. So I'll put a 2 here. It doesn't really matter which one you put it in. And then I know that I'm going to have a positive one and a negative one, or a positive number and a negative number after my x's. I just have to figure out where they go. So I know that when I FOIL everything out, I need to get -3 at the end and then -5x. So one thing I can do is I can say, well, I know this gives me the 2x squared. And if I do my outer terms, 2x times this number, let's make it -3, will give me the -6 I want. Okay. So usually I just think, okay, 2x times what gives me a -6x. So that would be the -3. Because remember, I want to have -6x and then I want to have the +1x to give me my +1. So when I do my inner terms, that's going to be where the +1 goes. And then +1 times -3, my outer terms, gives me -3. So this works because -6x plus 1x gives me the -5x I wanted. So it's just a way you can kind of guess and check. I don't think you'll get one on the test where you have a number in front of A. I know it's kind of tricky, but really just focus on the fact you know that one of the x's has to have a 2 in front, and then you can kind of guess and check what numbers would go in the remaining spots. If you wanted to do box method, I can show real quick. Here we put the 2x squared. Here we put the 1x and then -6x from those two factors that we found. And then here we put the -3. Then you just do greatest common factor. The greatest common factor of 2x squared and 1x is x. Greatest common factor of -6x and -3 is -3. Great, and then I can think x times what gives me 2x squared, that would be 2x, and x times what gives me 1x, that'd be +1. So that's what we got, 2x plus 1 and x minus 3. Last thing you do is solve. Don't really stress about that. I spent way too long doing that. So if I subtract 1, I get 2x equals -1. Divide by 2, x has to be -1 over 2. And if I add 3, x equals 3. I just have to see if I have an extraneous solution. So if I were to plug in -1/2, doesn't look like that would give me 0 in any of the denominators. But if I plugged in 3, I can see here I would get 1 over 3 minus 3, which would be 1 over 0. So 3 is an extraneous solution. I mean, if it helps you, you can write out all the work to check, but it's really not 100% necessary. If you can just look and see if you would get 0 in the denominator, that will tell you if you have an extraneous solution. Again, I know the factoring was like maybe not great, or you forgot how to do it when you had the 2 in front. You do definitely need to remember how to factor, but don't worry too much about it, like remembering the box method or anything. Just make sure you understand the process of solving these equations and checking for extraneous solutions. Very important. Okay, good luck.